Okay, so very quickly about the quiz that you just took. So many people did very well on this quiz, which is great. Keep up the good work. I will say that there is a danger of people being a little bit misled by the results of this particular quiz, because this quiz is definitely the easiest of all the quizzes and all the tests we have all semester. I promise you this course and the quizzes and tests will get harder. I'm not saying this to scare you. I'm just saying that you may need to continue to work as hard or harder to maintain, depending on how you did on this particular quiz. So if you did great, then super. Keep up the good work. Might need to work a little bit more because the material is getting harder. If you had some struggles, come see me. We can try to get you caught up and back up to speed. Just a quick reminder, there is another class between the Math 090 and this one, and so if you're feeling overwhelmed by the material in this class, let me know and we can talk about the potential of maybe switching into Math 094. Last thing about the quizzes, I do have some extras. I had too many copies for how many people took it, so if anybody wants just to practice with this, I'll put them over here and you can try practicing there later or sooner. Okay. So let's jump in. So today we're covering a section and a half as usual. So we start on page 49 of the packet. So let's jump in here. Okay. So we'll start here in the middle of the page on 49. Who's ready? Julia, can you read the objective, please? Okay, great. Holly? Okay, so the first two problems are everything that is left over on this page. So 1 and then 2 has a bunch of parts, including this graph. So give those a shot in your groups, and then we'll come back together. So I think most groups have finished or just about finished that graph, which is great. And on the next page is our full class discussion of some stuff. So let me just say, generally speaking, of course, tables will finish the different activities at different times. So if you ever finish, I know the temptation is to then just start chatting about whatever the weekend was like for you, but I would much prefer if you went back in the blue and found something that was not done yet, like the arithmetic that I just pointed a bunch of people to. So there's always plenty of problems to do. And one other thing about the quiz before I kind of forgot to mention it before. Some people are having trouble with the arithmetic of fractions. The first problem was adding two fractions together. I promise you that some of you are going to lose another 10 points on the upcoming test because you're still not there with fractions. So if you lost 10 points, or if you lost 5, if you lost anything on that fractions one, you have a choice to make. You can decide that you're going to continue to lose points on fractions, or you're going to decide that, you know what, it's just time to learn how to deal with these fractions. Even though I don't like them, I'm going to learn how to handle them because I'm tired of losing points on tests and quizzes. So if you're ready to make that jump, I have places that you can go to practice with the fraction stuff. But I promise you the stuff that you see here is not going away. So I'm hoping that people will not just look at the grade and then shove this quiz at the back of the folder, but we'll take the time to figure out, how to do things differently. There is an answer key to the quiz. Let's see. I have my own answer key here, so if anybody's interested in looking at it, you're welcome to. I'll put this up here next to the blank quizzes. But also there is an answer key to this quiz, and there will be for every test and quiz in the Math Studio. Do you guys remember where you got the folders with the 095 letters from previous students? So on that same desk on the back wall, there's a binder that says answer keys to 095 or something like that. And so you can always take a look for the answer key for the quizzes and tests, and there's the same thing in the library on reserve. So if you just ask them for the Math 095 folder, they can give it to you, and you can take a look at the answer key, and it will be updated right after every test and quiz. Okay, so coming back to the graphing stuff, there's this important relationship between an equation, a table, and a graph. So for example, so the equation that you guys just had, well, I can just highlight it here. This is the equation you had, right? W equals 10H. And so, for example, if you plugged in H equals 7, just making up a number, then what do we get for W? 70 is W, right? So 70 is 10 times the 7. And so the point 7 comma 70 is a solution to the equation, right? It makes the equation true. And that point 770 might also appear in the table as an ordered pair. And then that point 770 also appears as a point on your graph, and you connected the dots and got a straight line. So there's this kind of three-way analogy happening up here, three different ways to say the same thing. A solution to an equation corresponds to an ordered pair in a table, which corresponds to a point on the graph. Points on the graph are equivalent to solutions of equations. Okay, so it might be easier to look up here because things are color coordinated, whereas yours is just one color. We've got some vocabulary here. The H is called the independent variable, and the W is called the dependent variable. And I'm hoping that the vocabulary will make sense. Which seems more reasonable of these two scenarios? You work a certain number of hours, and as a result, you get paid a certain amount of money, or you get paid a certain amount of money, and as a result, you work a certain number of hours. Which one is more natural to you? First one, right? You work, and as a result, you get paid. You don't get paid, and then as a result, you go work, right? So the thing that is completely independent of everything else is how many hours you work. You go out and you work a certain number of hours, and that's it. And then as a result, your wages depend on how many hours you worked, right? So that word depend right there is the same word that we use in English. How much money you make depends on how many hours you work. Thinking of it, forgetting about the specifics here, there's a little thing that if you can just remember, you'll get this question right every time. The variable that's alone is called the dependent variable. Just the one that's alone is always the dependent one. Things are color-coded here. The independent variable always goes first in the row, first row or first column. Dependent variable always goes second. Following that blue over here to the graph, the independent variable is always on the horizontal, and the dependent variable is always on the vertical. And in terms of ordered pairs, independent variable is first, dependent variable is second. Those two numbers are each called coordinates, right? So lots of stuff kind of all related to each other here. As you're working through the classwork in just a moment, maybe refer to this, come back to this if you need to. If you can't figure out, well, which letter goes first in the table or where do the variables go on the graph, come back to this picture, okay? All right, so there's some notes for later reference. You can take a look at those another time. But for right now, move on to the next page and let's see how far we can get in the classwork. Raise a flag if you get stuck, and also I'm going to come around and start checking homework now. Okay, so just to conclude, it looked like we were working really well on all the dependent, independent variables, the relationship between an equation, solutions to the equation, tables for the equation, a graph of the equation, all tied together. But in some sense, there's just some memorization or some experience that you need to gain in order to be really comfortable with all that information about, well, which one goes first, and which is the first row, which one goes on the vertical axis. All of these questions about dependent variable, independent variable, it comes with either just like brute memorization or probably better, just lots of practice. And so keep referencing that one page that I had up here in color a few minutes back that tells you exactly where everything goes, all right? It's just something you got to do enough until you get it. Okay, on page 60, just a couple of administrative things. Let's see. So first, if you borrowed the photocopy of the first 4 sections of the book, could you return it to me at the end of class today? Thank you. Don't forget, negative numbers are coming soon, and if you have troubles with negative numbers, they probably showed up on the quiz, but if you have trouble with them, lots of places that you can go to practice negative numbers. Definitely take action if you have any uncomfortableness associated with negative numbers. A note about calculators. We're not going to use them very much at all this semester, but soon we will need one, and it's got to have an exponential key. That's one of these 2 buttons, and the symbol pi. There's one calculator that we strongly recommend. It costs about $20 at the college bookstore. If you already have a calculator, show it to me, and I will let you know whether or not it's sufficient. But anyway, that's coming. So hopefully you can get a calculator soon if you don't have one just yet. All right, so let's jump to the objective here. Can we go to Randy? Can you read the objective on 61? Okay, so let's consider the equation. 9.6 equals t plus 2.08. To solve this equation, we would, and now we got to come up with something that we're going to do to both sides of that equation. And in some sense, this might be like the first moment in our class. So we've been meeting for like 2.5 weeks. This might be the first moment in our class where you're like, oh yeah, finally, algebra. Like this looks like traditional algebra, solving equations. That's a lot of what you've seen in algebra. So, so what are we going to do to solve this equation for t? Subtract 2.08 from both sides. Tyler, can you repeat what you just said about the isolate?
We do it because we have to isolate the t from the 2.08. And so by subtracting, we're canceling the 2.08 out.
Does that make sense? We need to isolate the t. That's what solve means. It means get the variable by itself. Some evil person has taken our poor variable and added 2.08 to it. In order to get that 2.08 out of the way, we need to do the opposite. We need to subtract the 2.08, right? Just do the opposite. Okay, so we're going to solve the equation here. So I'll just copy the equation again. 9.6 equals t plus 2.08. And then I'm going to write all the details, and I'm going to encourage you, encourage is too nice a word. I'm going to require you to write all the details for a little while. I won't require this all the time, but until I'm sure that everybody's where they need to be, I'm requiring this level of detail. So we're subtracting 2.08 from both sides. One of the two most important rules in all of algebra. Whatever you do to one side, you got to do to the other. So we're subtracting 2.08 on the right because we want to get rid of the 2.08. We're subtracting 2.08 on the left because that's the law. Whatever you do on the one side, you got to do on the other. Okay, so let's see what we can do here. So the 2.08s cancel, right? Plus 2.08 and minus 2.08. That's why we put it there, is to make them cancel. And so what remains on the right-hand side once those cancel? You're telling me on the left. What's on the right first? Just t, and that was the point, is to just get t by itself. And now we got to do this arithmetic. Now, sometimes the arithmetic is easy enough that you can just do it in your head, and you just put it there. But I wouldn't be surprised if some folks wanted to, needed to write out a little bit of the detail. And so traditionally what you do, if you need to write out arithmetic details, you put them on the side so they don't clutter the main algebra part of the process. So subtracting these things without a calculator, probably want to fill in what's the missing number in this space. All right, so 0 there, and then we subtract very carefully. Go ahead and subtract without a calculator. $7.52. And so we bring that back from the side work over there, and this is our answer, 7.52. Okay, next step here. It says this solution is correct if the numeric equation blank is true. So this is really just asking us to think about what it means to check our work, what it means to know that we've done things correctly here. So go back to the original equation. The original equation said 9.6 equals t plus 2.08, right? Okay, well, we have just found the value of t, and if we did it right, then the value of t should make that equation true. So I'm going to put a purple number in here. What am I putting? 7.52. So that's copying the original equation, everything as is, except the t, which becomes the number that you just solved for. And then we can show our work to check that the equation is true. Now this might seem like overkill, and I apologize. Certainly this is one of the easier equations we will be asked to solve this semester, but it's really about the process and developing good habits so that when we get to much more complicated equations, we've got the habits in place that will allow us to solve them. So we add up here, 0, carry 1, 6 there. Did it work? Yes, 9.60, and it worked. Okay, and the last thing before you guys will jump into the classwork again. So when you are adding or subtracting a number from both sides, typically you just write that directly below both sides of the equation, and you do your arithmetic and you write your answer. But it looks a little bit different traditionally when you're doing multiplication or division. So for example, if I had this equation, 3x equals 6. Okay, so it's really clear what the answer is. Probably don't have to think too hard to figure out what x is. But if I'm just following the process, somebody took our poor little x and multiplied it by 3. What's the opposite of that? Divide by 3. And so instead of saying like divide both sides by 3, we typically don't write it that way, which is how we wrote the subtraction up above. So typically what we do is actually just write a fraction line on both sides. Say divide both sides by 3. And you get x equals 2. If we had something like this, x divided by 5 equals 7. Somebody took our poor little x and did what to it? They divided our x by 5. What's the opposite of that? Multiply by 5. And so this one goes in a different place than either of the other two things we've done. Typically, you write it directly next to both sides of the equation. And instead of putting it below multiplication, typically you just put it right next to it. And the 5's cancel, which is why we put it there. We get our answer, x is 35. Okay, now the equations that we're solving today are the easiest equations we're going to solve all semester. So it's really not about getting the right answer. I want us to get the right answer, but additionally, it's about building these good habits. And so I'm going to be really, really picky and a little bit of a meanie today in the rest of this section, just making sure that we're following this process, even though the equations are so simple that you could probably do without the whole process, all right? So just bear with me today. Okay, classwork starts on the next page. See how far you can get. Sorry, classwork doesn't start on the next page. One more page. There it is. Middle of 63. Middle